EEG as one. So we're really thrilled to have you guys here in person and online this evening. Just a couple of little housekeeping tips. If you need the bathrooms, ladies, if you just go out this door here and to your right, there's a bathroom by the stairwell. There are swipe cards that need to hang down when the doors are locked at this time. Take that in with you so you can get back in. There's an exit button to press. Now, gentlemen, please go out and pass the lifts and hang a right. There is a door, but the button to get out is about here. We've caught many people just trying to force it. Also take the swipe card with you. If there is a fire, you will hear a fire alarm. Our nearest exit is by the ladies' toilets here. Just please exit out through there. When you come out the front of the building, we do just need to cross over a street here, Luke's Lane. Please check that no cars are coming. Cross over and we'll just wait in front of the Teppanyaki restaurant and until we're all clear. Myself, and I just probably should have introduced Caitlin, who's on IT tonight. We'll both be here. We'll be here to look after you and direct you. If there is an earthquake, please drop cover and hold, and we'll let you know what to do when it's safe if we need to evacuate. If there's a tsunami threat, we're told just wait here in the building. If we do need to evacuate, we've got to trek up the hill to the War Memorial, but we can cover that off if we get to that. Right, without further ado.
Cool, thanks, Alana. Okay, I think we're online. Everybody can hear and see. So many people. Cool, good evening. My name's Chris Lambell. I'm the Deputy Chair of the Electrical Engineering Group. This is our 11th presentation of 2013. As well as our EEG members, we welcome members of the IT, the IEEE, IES, SIGRI, SIBSI, and anybody who wants to learn a few things about engineering, really, all are welcome. Well, I've got a captive audience, a few upcoming events. Wednesday the 13th of December is our end of year review, where we just have a chat through what we've done over the last year, talk about what we're looking at next year, and chance for feedback. And if anybody wants to offer to present next year, it's a good forum to discuss. 2024, which is coming rather fast. February, we've potentially got an acoustic engineering presentation focusing around generators. So it's electrically orientated. Wednesday, 13th of March, we've pretty much got NHP lined up to do a presentation on IEC switchboard standards. Hopefully in November next year, we've got our MCONS conference, which is where we combine our electrical engineering group and the mechanical engineering group for a combined conference, and hoping to lock that in for November at the AUT. So fingers crossed on that. So tonight, if you want to present, let me know. Please get in touch. I can always find a forum for you. Or if you know somebody wants to present, put them in touch and we can join the dots and make it work. So a few rules for tonight. The Zoom Q&A will be on. So if you've got questions, please answer them. Please put them up. Questions will be answered at the end, ideally, unless there's something obvious, in which case we'll kind of interject. But ideally, we'll hold them to the end. Try and keep the flow of the conversation going. We're talking as friends, sharing knowledge and ideas. So no silly questions. Nothing wrong with asking questions, of course, but we do this to share knowledge and ideas. If you think you know more, then please get in touch and you can do your presentation. I think that's us. So tonight's presentation, we're lucky to have Robert and Ruben from WMAC presenting on electrical demand response. Flexibility is critical at Electrify New Zealand, which is a good topic because over the last month, I think there's been more conversation around demand response and managing capacity in the network and grids. So I think you probably got the right timing for this. So I'll hand over to Ruben first.
Yeah.
Cool, thanks.
All right, can you hear me all good? Okay, so I'm Ruben, obviously. WMAC's been in operation for about 7 years. We're a team of 5, but we do have a lot of support from multiple institutions. We deal closely with University of California, who have a lot of our data and use that for customer benefit and for also understanding what we actually need from the data. We also operate quite closely with Canterbury University. Here's a range of our technical team, including Robert himself. I am not technical by any standards. So anyway, I'm just going to start by framing the whole condition of the market. Everyone understands it. Everyone knows it. We have goals of net zero by 2050. It's mandated by Zero Carbon Act. And this means a lot of change is going to happen in the market. So for starters, there's going to be a lot more infrastructure. That's going to be generation, and that's also going to be the components down at consumption. So that will be transport, hot water. There'll also be other components that we will not foresee. and I won't go too much into the details of all the little facets of it. But there's estimates of grid upgrades of 20 to 30 billion per decade for the next 3 decades, which in my eyes, the consumer should never wear. So the other component that we sort of need to talk about is decentralization of energy. So we're going to be looking at demand energy resources like BESS or rooftop solar. In Australia at the moment, they're already limiting exports of solar and paying through the teeth for old contracts that they don't really want to maintain but can't get out of. And then we've also got the components of weather. And as we build more renewable generation, large quantities of it are not baseline generation. They're available when the weather decides it's available. And traditionally, we have not changed our consumption habits based on weather. Actually, if there's bad weather, we probably consume more. So just a few hot takes. We had August 9th last year, 30,000 houses out with a frequency event, and then also like solar and EV are already destabling localized network devices. So my background's actually commerce, and I am a dreamer about being an economist one day. So I brought out a supply demand curve for everyone. So our big solution is demand response, what we choose to call flexibility, because we don't believe in exclusively load shedding. So we believe that demand response is load on, load off, and moving loads out of constraint, and also consuming on surplus. Demand response has the ability to fix a whole load of costs that are associated with all the pricing pressures on the upwards component of the market, which is grid constraints. So we could reduce fixed costs on upgrades, or not reduce, let's say reduce pricing pressure. And then also we can reduce the risk premium in the market if there's enough aggregated load that is switchable. And then there's also the added benefit of carbon emissions from thermal peaking. Obviously, a lot of this stuff will be rolled off in the future, but at the moment, we burn a lot of carbon on the coldest days of the year and peak. So also we want to talk about what are key demand aggregation opportunities that we personally see is water. So we consume a lot of energy on heating water and pumping water. Additional components would be HVAC and cool stores. So we believe in thermal mass as an efficient battery store. So hot water, cool stores, great option. And then there's the components around EV charging and inverter. And we're not going to talk about battery to grid because that is non-existent at the moment. Well, no, in an EV space. So what is WMAC doing at the moment? We actually started in the transformer monitoring space, and we might, I don't know if it's true, but we might have the largest LV monitored network in Canterbury at the moment. So this device, we sort of thought would give the EDBs or the electrical distribution companies the ability to have real-time visibility and through alarms and through real-time reporting, which would allow them to be more responsive and also plan their assets better for the future. Global reports suggest that less than 1% of LV assets in the world are monitored at this moment in real time. And the other thing we're doing, because LV monitoring is in a growing space at the moment, is we got involved in demand response. And at the moment, we are controlling hot water, pumping, and inverters, and we've even got an ice skating rink in the winter that we were managing for a bit of fun. So as there's no pricing mechanism for demand response at the moment in the market outside of reserves, we have to find efficiencies for our customers. So for our customers, we're trying to find efficiencies through reduction in volume and through time of use pricing. So at the moment, we've just released a product we call Synergy Heat that is basically doing a range of just-in-time services and pushing the load out of peak. And we're finding just from not maintaining charge temperatures, we can find about 10 to 15% efficiencies. And then through pushing them into time of use pricing, depending on the differentiation, we can find additional benefits. At the moment, some of the customers are about 7% pricing benefit from just taking on the benefit of time of use pricing, but not all people are exposed to that, obviously.
So the other thing we're doing is irrigation pumps. Now we're talking reasonably large pumps here, between 80 and 200 kilowatts. Being able to give the farmers better control of them, being able to turn them on and off when they want to, but also we can follow. Some of these farmers are exposed to the spot price. So if the spot price gets too high, we can turn them off. And also there's a lot of solar coming on this year. So there's a big concern that at 2 o'clock in the afternoon, we're going to have more power than we know what to do with. So maybe what we do is we can start turning stuff on. And I think one of the things I think people understand turning things on and off and moving them around. That's all right. But one of the things we're going to have to do, and this is very contentious at the moment, but I want to come into your house and turn your heat pump on. And I'll give you an example why. Okay, so I'll come back to this point because we're getting a bit ahead of ourselves here. So we believe in a bottom-up approach to this. At the moment, we have demand response in New Zealand. Camalco might do us a favour and turn a pot line off. Fonterra plays in the reserves market and will turn stuff off. But essentially, the only real thing we have at the moment is we can turn hot water off in the house at a residential level. And actually, we were world first 60 years ago. We were hailed as champions. And to be fair, it still is probably one of the biggest systems of its type in the world anywhere. But we've let it go to rack and ruin. Probably half the houses in New Zealand are no longer controlled by Ripple. In fact, probably more than half. So most people nowadays have gas colophants, and we know that the government was trying to put an end date on new installs. So that over the next 10 years, though, everyone's going to move back to electric. And to be fair, the retailers have discouraged it. A lot of them want flat use rates, so to discourage people from using time of use. And some of the older members of this audience will remember, night store heaters and off-peak rates and stuff like that. At the moment, for most people, maybe Flick and a couple of the others are a little bit different, but most of the gen retailers will lucky if they give you 2 or 3 cents for peak and off-peak. And there are literally thousands of price plans out there, but most people will never really understand them. So we think it's very important to be able to turn things off, especially on those really cold nights when we're trying to cook our dinners and stuff like that. But we also need to be able to turn things on. So when we've got this excess solar, we can maybe pre-cool your house. So for example, in Melbourne, they're exporting on a good Saturday afternoon at 2 o'clock in the afternoon, they're exporting power to New South Wales. They paid a lot of money for it because it was on old contracts, and then they have to pay New South Wales to take it off their hands. And the line losses between Melbourne and Sydney is wasting another 10 or 15%. So you've got all this power that you've paid too much for, you have to pay to get rid of it, and then you lose it all in heat in wires. Wouldn't it be better to turn everyone's heat pump on at 2 o'clock in the afternoon so that when they come home at 5 o'clock and the kids are all hot and sweaty and mum and dad are all hot and sweaty, what do? They turn the AC on cold, the kids go and have a shower, and they start cooking dinner. And they go from 4 megawatts of export to 7 or 8 megawatts of import. And in the space of a couple of hours, it's phenomenal. So we want to be able to have a discussion with end users to say, can we do that sort of stuff? And then how do you do it and deal with it in your power bill? So you can see there's quite big disruptions through the whole market here. But our approach, coming back to, is and this is now we're getting into people who understand the grid. We believe that the distribution transformer is the key. It is the one point in the network where you can look up and you can look down. And it's the point that comes under the most stress. So it's the single A phase that comes down the road and goes in. And tonight, all the customers that are on A phase have plugged their EV in. And you've now got 3 7-kilowatt EVs wanting to charge at 6 o'clock at night in July while mum's cooking dinner, the kids are in the bath, and we're literally going to melt the terminal off the transformer. All right, so what we need to be able to do is say to those EVs, can you just calm down or go away for a couple of hours? And I've done some EV sizing for some buildings in Auckland, an apartment building. They literally max out their connection within 5% of their connection capacity through 6 o'clock, but they have nearly 5,000 kilometers of charging capability between 9 o'clock and 6 o'clock in the morning. So if we're smart, 9,000 kilometers is a lot. That apartment won't drop. Oh, sorry, 4,000 to 5,000 kilometers is a lot. Every night they could charge their cars. So yes, they can't charge when they want to, and yes, if they come home flat and they get a call out to the hospital at 9 o'clock, it could be a bit of a problem. But for 99.9% of them, they're not going to get down to their car till 7 o'clock or 8 o'clock in the morning. And in which case, they may not have been able to fill them up, but I can give them a couple of 100 Ks. And so they're the sort of things that we just got to be a lot smarter. And you and I as customers have got to be a little bit more considerate. The alternative is we're going to pay through the nose. And there was a comment from Peter, I can't think of his name here. He was the ex-ENA chair. He reckoned power prices could double. Right. And because literally there's reports that says basically if we electrify every transformer, every cable in the world has to be replaced. Now that's a bit extreme, but the reality is that's what's going to happen if we carry on the way we are. And to be fair, I reckon I can manage your house, save you money, and you'd never know I was doing it. So we'll throw you over to the floor. Oh, we've got another. Oh yeah, sorry. One more slide. Okay, so you can do this one. Yeah.
So we will actually open up to the floor after this for questions, and we'd really like your engagement actually. So our opinion of obviously the transformer being the control node controlling loads downstream, we believe that this has the power to benefit all players in society and in the game, maybe except for the gen retailers. We believe that it will reduce pricing pressure for consumers in both fixed and variable costs. And then also the flexibility suppliers will likely see either rebates or tariff reductions for participating in the market. EDBs will get the benefit of reliability and better asset utilization, which is beneficial for everyone else as well. And then Transpower, hypothetically, if you get enough aggregation in our delusions of grandeur, they wouldn't need devices for frequency events because they just wouldn't occur. And yeah, we currently, so sort of like our sign off, we currently build for the 200 hours of peak load per year. As consumers, I don't think the average household can actually afford to justify continuing operating that way. So I think, yeah, if we maximize and utilize our assets better, we can reduce a lot of upward pricing pressure on transmission in the electricity market.
Yeah, there is going to have to be upgrades, but there's a lot of places where we could
slow it down.
Yeah, use it much more wisely. And then we could actually then focus, because at the moment, the amount of visibility in the network is pretty poor. And so it's going to make it very difficult for us to make the best decisions as to where to spend the money. So we're going to wind up spending a lot more than we need to. And we also haven't taken in, for example, and again, we're getting a bit evangelical here, mode shift is going to have to happen because we can't replace every petrol diesel car with an electric car. So we're going to have to change some of the things. So that's going to make a big difference. The EDBs at the moment are really nervous about, if you got 200 car parks and you want to and I've already spoken to people, no one's going to come down and unplug their car at 10 o'clock at night and give it to somebody else. Nobody wants to share and it gets quite complicated. So basically, if you've got 200 car parks and there's going to be 200 cars, sometime in the future, there's going to be 200 electric cars. And 207 kilowatt chargers is a big transformer, a lot bigger than any building currently has. And that's a big financial upgrade for the poor people who live in that building. But in reality, how many Ks do those 200 cars do in a year? And if you divide it out, they don't need a lot of charging. What the biggest problem we have is on a long weekend, everyone comes home on Sunday night and everybody's got a flat battery and everybody wants a full battery on Monday morning, whether they need it or don't. And that's the thing we're going to have to say. I don't mind if my car takes all week to get charged up fully, because the reality is I drive 40 Ks a day, you know. As long as there's 40 Ks in the tank, who cares? And once we do that, we're going to be fine. Well, maybe not fine, but a lot better than we proposed to be. What's the next one?
That's
That's
it.
right.
That's it. That's my
So,
references.
yeah, throw it out to questions.
Cool, thanks guys. Any questions in the room? So speaking to mic so people online can hear.
Thank you. Hey, my name's Siobhan Bradley. I'm working at the Commerce Commission, but I worked for a gentailer in Oz before this. I was just wondering, like, what the level of visibility is that you can get down to, and like what the agreement with the consumer looks like. What kind of, like, how you gain access to their data, and what kind of agreements there are about how they can benefit.
Can I do this one?
Yeah, you can do this one.
So actually, our vision isn't in process yet, but we imagine that there's going to be a lot of community engagement about changing of behaviors. But the reality of what we think the device should look like is that there's very limited influence on what it will actually have on their life with us controlling them. So we are looking at doing a partnered project with a few different distribution companies at the moment to do that project. And we're looking at phase 1 to just be hot water, EV chargers, spa pools, and pumps on pools, just because they're easy. People aren't going to notice if they go off. And actually, we can profile hot water really easy by charge times. So if we actually know when the hot water is charging, we actually know what that house's behavior is like. And we could do that in a completely anonymous way. And the vision we have is the transformer does all the controlling itself. So it gets to know the devices downstream and it starts controlling them from itself. And then the only external factor would be if the EDBs or Transpower requests that we reduce the capacity of that transformer for a set period of time.
So if you look at the Dunedin study, they did 1,000 hot water cylinders for, I don't know how long. It was a lot of data. I got given it once and couldn't find anything that I could open it with, so I've never really looked at it. But a couple of guys I know have looked at it, and there's about 5 or 6 profiles that we all fit into. So, there's we hit the people who get up and have a shower first thing in the morning, and then basically all the hot water does is keep warm during the day, and then it runs again at nighttime. Well, if you know that, then we just need to have it hot at 6 o'clock, and we can turn it off then, and that means we don't use it at all through the morning peak, and then we know that today's a really hot, sunny day. So we'll heat it at 2 or 3 o'clock in the afternoon when there's excess solar and there's some cheap power out there. And then basically we might just top it up at about 9 o'clock, just so that when you have your 10 o'clock shower, you're away. All right. And it's very easy all we're looking at is the current. So all we need to know is, it went on. And so we can learn when you have your showers, and then we can move it around. And we can computers are cheap. And we're not talking about trying to manage 1 billion hot water cylinders. We're talking about one transformer controlling, at worst case, 150 houses. So 150 hot water cylinders. That's a $2 micro and 2K of RAM, So you can learn quite quickly what to do and then just turn them on and off. You could do it today with in fact, I was talking to one of the girls today about use a schedule, like a little clock to turn your under. She was moaning that her under for heating costs $5 a day. So turn it off through peak and get a good off-peak plan, and that will make quite a big difference. So you could do the same, but we need to be a little bit more finesse with that because of solar and wind and weather events, that we might choose to move that around a little bit, almost from a day-to-day basis. But that's really easy to do, very simple signals.
So in this scenario, is it more like you have an agreement with the distribution, with the EDB, and then they kind of optimize everything and the consumer benefits in the lower prices, so they opt into it?
The EDBs don't have relationships with customers, right? So the only relationship at the moment is with the retailer.
Yeah. So your
So-
relationship is with
So the retailer will then have you on a time of use charge and would have already got well, we're talking simplest terms. So controlling your heat pump is nobody's talking about that at the moment, right? But if you signed up to Hot Water Ripple, you've agreed to allow the retailer, technically he doesn't, it's the EDB that does, to turn your hot water off. But at the moment, they just turn it off at peak demand times. What they should be doing is turning it off at 6:30 every morning and turning it back on at 9:30 in the morning. So you miss out that morning peak, and then do the same thing in the evening. Turn it off at about 4:30, 5 o'clock, turn it back on at 9 o'clock. And that would then save you 30 to 40 cents per charge time, maybe 60 cents a day. That's worth having, over a year, over 10 years, that's a lot of money. And at the moment, that's actually a wealth transfer between you and I and the generators and the retailers. So hopefully there's no retailers in the room or generators in the room. But they're the simplest type things that you can imagine can happen here. And they're very subtle. But with that control, you can then, if the wind picks up and we've got surplus power, we can charge your hot water cylinder up.
I was going to say also, we imagine a world where there's flex providers. So it would be 4 players in the market. It would be generator, retailer, distributors, well, 5 Transpower, and then flexibility providers or flexibility aggregators.
Yeah.
What sort of efficiencies do you think you're going to achieve through this?
Well, there's the biggest problem we have at the moment is that we build for 200 hours a year, and the rest of the time the network's completely underutilized. We're already pouring water through dams to keep the fish alive. That I've got a friend of mine who's got a company that puts data centers right next to hydro stations and next to wind farms, so that when nobody wants their power and they're still having to run water, he'll use it. So the efficiency numbers, in the dairy shed at the moment, just by moving to just in time, they waste around between 8 and 12% just keeping hot water hot unnecessarily. Peak and off peak, because the differential between the peak price and the off peak price probably saves them 6 or 7%, not very much, right?
A lot of the research shows that instead of upgrading transformers, we're going to move to battery energy storage, so that the transformer charges the battery during off-peak times and reintroduces the power when the demand comes back on, instead of overloading the transformers. Have you guys factored that in?
We actually believe that turning stuff off is a lot cheaper than investing in batteries. And also, all the geopolitics around the world suggest that there's going to be pricing pressure on all the componentry that goes into batteries. So although battery pricing pressures are going down in technology, all the commodities that go into it are going up. I'm not going to sit here and pretend that I know the figures on that, but I think we do need storage solutions, but I don't think that we can look at the future holistically and say storage is going to be the only solution. It will be part of the solution.
Yeah. And the other problem we got is there's still the cable in the road. It's only going to carry 50 amps or 80 amps. And so making the transformer bigger artificially isn't necessarily going to, it's not just the transformer you have to upgrade.
Do you see what we've got online quickly? Okay. Surely infill housing is a much bigger issue than EVs and is the larger driver for asset upgrades. with all these questions, you don't need to answer any of them. So,
yeah,
Robert.
No, it is a big problem. But we're not saying you're not going to upgrade. What we're saying is that we've got to be a lot smarter about where we are. Yeah.
we'll try and get through some of these quickly. How does your monitoring system work?
Well, essentially, it's just a smart meter that transmits data either over some form of radio network. We currently support cellular and Sigfox, which are two IoT networks, and bring it back into a cloud service. And we currently bring back 10-minute power reports, which are voltage, current, phase angle, and we bring back some daily power quality reports and temperature, transformer temperature. But we can bring back lots and lots of data. We just don't quite know what to bring back at the moment, and we're conscious that too much data becomes a problem.
And is expensive.
Yeah.
How would you incentivize customers to allow a utility to control their loads like this?
We don't believe that it would be utility, it would actually be a flex provider, but we believe that the utility should offer a tariff on their daily set fees, or SEA has indicated that they actually want the EDBs or the electrical distribution companies to set their off-peak to 0 on
So
kilowatt hours. That's, they've sort of got targets for 27,
27.
and they want it all below 2 cents.
And so at the
you-
moment, if you look at your power bill, there's not much different. Well, it's generally a number. They don't differentiate between the power cost and the lines charge. I think there's a lot of people, not so much residential, but commercial, where the lines fees is as much, if not more, than the power charge. So if you can get a 5 or 6 cents per unit reduction in your lines charge, and your retailer is saying 27 cents for peak and 12 cents for off peak, suddenly 17 cents incentive that's going to make a difference to someone's power bill. I mean, we're talking, if we get the right numbers for irrigation pumps, we're talking 20%, and on a farmer who's paying $700,000 a year power bill, 20% is a lot of money.
Also, to put things into perspective, there's one DER tariff, Demand Energy Resources tariff, in existence at the moment that I'm aware of, and that's in Auckland. It's a residential one. I don't think there's anyone on it, but I did some basic math, and the average household would save about $3 a month, and that's on pre-existing tariff structures. And I would imagine that that will grow in volume over the coming years.
Yeah, and I think if we can show you a 10 or a 15 or maybe, and remember that if you're charging your EV and you've moved to full electric, a lot of us are going to have $200 plus power bills on average. My power bill for 2 of us is already well over that. And, 20%, 15, 20% saving, that's worth having. And if we do it properly, you will never know we're doing it. Most people don't even know what Ripple is, and yet half the houses in New Zealand have their hot water cylinders turned off regularly.
Stretch, but
Yeah.
Take one more quickly online and we'll jump back to the room. How do you make sure that hot water cylinder or EV charger responded to the flexibility event?
Because our device actually knows what the current, that there's a current measuring device in there. It's not measuring the current, but it knows that it's on or off. And so we know that the device has responded to our request, and its natural position is on. So if it doesn't get a message, it's just on, right? So we hold it off. And so if there's any problem, its natural position is to go back to on.
Got any questions in the room?
So that's all measured from the transformer level? Are you putting any kit into the
No, we're putting
household?
kit in the house.
You're putting kit in the household as well? Yeah.
Yeah, that's the only way you can. I mean, hopefully one day I might get a hot water manufacturer to give me a smart relay that I can talk to in their thermostat.
Yep.
But there is a couple of smart manufacturers around at the moment. Their sales numbers are so poor, it's ridiculous. It's not just
Panasonic as well.
Yeah. So yeah, the retailers, we talked to Fisher and Paykel and to Panasonic, and they understand that this flexibility is really important. They're real keen to, if we can agree on anything, they'll put it in their hardware, because the build costs for this sort of stuff, the BOM costs we worked out for Panasonic would be about $5 a device. If they put it on their circuit board, it's about, we can probably build something for $20 BOM, that's not the cost of the item to the customer, but that's the, you know, the component price to build it. And so it's not expensive, but at the moment, yeah, very frustrating. Whatever we do is going to cost us more to install the kit than buy the kit.
Really interesting idea. A lot of my clients that I deal with have no interest in someone else controlling their hot water. So when I do their switchboards, I chuck the Ripple in the bin because they're fucking ugly and they don't want them. So how are you going to convince people to get something put in their house? And also, what's the flow of capital, as in, does the client or the residential user have another bill coming in as well?
No. So
on top of?
no. So the Ripple relay at the moment, if you threw it in the bin, your customer's still paying for it because it's one of his fixed charges in his their retailer pays it for them. So the expectation is that the relay is there, even though you didn't install it. We're expecting that what's the incentive? The incentive will be price, simply because if we don't want to build for those 200 hours and we want a much more smoother demand curve, the only way we're going to get that is turn stuff off, and either you do it and move all your stuff manually into off-peak, or you let us do it. But we can see peak prices going up considerably high, and hopefully off-peak going the other way.
Well, so actually we were speaking to Greg Seiss, who works at EnergyLink down in Dunedin. They do a lot of the future market price projections, and they were showing us for this year that we've already seen multiple 5-minute tranches of $10,000 a megawatt. So that's 60 times the average price of energy in the wholesale market. Now, we've discovered that actually if government is excited by things and can get their heads around it, they'll actually push it. So we've got lots of subsidies around EVs, which will probably disappear, but there's a lot of chatter around EVs. There's a lot of chatter around solar. What we see is that until demand response is actually in the public view, and we talk about the fact that we actually need to consume energy smarter as a society, that yes, maybe there might not be easy consumer buy-in, but if you go knock on someone's door and you actually sit them down and actually talk about this stuff and why it's beneficial to society, I think maybe there will be a percentage of people who will absolutely not want people controlling their devices, and that's their prerogative. But I think there'll be a lot of people that if they can see benefits and price reduction for themselves, they'll fully be on board, especially if the return on investment is reasonable for them.
Yeah, I'm actually going to do some research on my spa pool after a discussion today. I'm wondering how much, because most people only use their spa pool once a day, right? And after looking at what we do in dairy, dairy sheds waste 10% just keeping hot water because they heat it straight after they use it, and then they keep it hot till they need it next time. So just that keeping it hot wastes nearly 10% of their power. Well, I know that for a fact that in the middle of winter, for 3 months, my spa pool cost me $200 a month, right? So if I can save 10% by just working out when I need to turn it on so that it's hot when my wife wants to get in at 5:30, I could save myself $20 a month, which for a little bit of sitting around with the computer on it might make me feel a bit better. And that's $20 a month is a lot of money, and it won't be as much at this time of the year because my spa pool comes down to probably under $100, but it would be then $10.
Well, if you can save money, keep your partner happy, that's priceless.
Yeah, as long as she doesn't want a morning spa, because then she might get a shock.
Okay, here's a good question. I've been promoting a smart thermostat for nearly 10 years. No one is interested because of the way the electricity market works. How do you propose to overcome this problem? Because the smart thermostat benefits everyone on the system, it should be funded by a levy on all consumers. The Electricity Authority is not interested yet. It needs to take the lead. Do you have a solution?
So we went down the levy hole for a very long time, and I think we've come to the conclusion that actually differentiation in price and on and off peak and appropriate tariffs would be sufficient for the average consumer. Whether or not you agree with that might be a different question.
Yeah, and for the person who asked the question, the problem you have at the moment is the differentiation is so poor or non-existent that there's no benefit in your product. And so we see a lot of hot water happening at peak times, and just consumers just do not understand that you don't need to heat your hot water straight after you had your shower. You need to have your hot water hot just before you have your shower. And once they realize that, and the fact that it might save them 50 cents a day, then suddenly your product might, at the right price point, be saleable.
Cool. How can we incentivize the gentailers for this?
That's a question for the authority.
Is there a future for reversible fuel cells under EDB ripple control in domestic and commercial new builds for local storage of excess generation and off-peak storage? So peak demand flattening is localized, i.e. taking the hot water energy storage to the next level, or potentially utilizing reversible EV charging.
To be fair, I'm too involved in trying to make something work within what we've currently got. That's a bit into the future. But what I'm proposing is once you make the transformer the control point, we can move the set point on inverters. We can tell EVs that we want some power off you to give it back. That can be very, very become far more sophisticated over time, as long as we've got the communication between a local device and the device we want to control. And so I think everything you're saying there has its place, but at the moment, man, we're just barely crawling. And that's a bit further in the future than I'm currently looking.
Cool. Given that you're providing a monitoring service, how do you propose turning off a hot water cylinder remotely?
So the monitoring service is separate, kind of, although it would be integrated into the EDB. Do we want to talk to the tech or not?
Well, simply the transformer has rules set around it by the EDB. So it's a 500 kVA transformer. It can't exceed 700 amps per phase. You might want to say we don't want imbalance of more than 15%, and you want to monitor the harmonics, because the one thing I'm really concerned about is all these inverters that we're putting on the network, and we have no idea what the harmonics and power quality issues they're going to put back in. And the only way to save a transformer's life from all this noisy shit is to derate it. So it might be turn stuff off so that we can protect the transformer. So what we're doing then is basically making a decision. Little micro EV charger turns up on feeder 1 A phase. It's very obvious. And that little the little device that controls it, sends a message, say, I just turned on. And I go, oh, you're on A phase, feeder 1. So I now know that if I've got a problem on A phase, feeder 1, I can turn off that EV charger and get rid of 7 kilowatts, right? And the same with the hot water cylinder. I learn where they all are, and I just ratchet them back as I have to. But what I want to take into consideration is power rates. So we would move all your hot water into off-peak. We'd move all your spa pool pumps and your swimming pool pumps. Because if your swimming pool pump's off for 6 hours a day, do you really care? Because it's 6 a.m. in the morning to 9 a.m. and it's maybe the 4 o'clock in the afternoon turning it off. But it's the middle of winter that I'm really worried. In the summer, I might make an exception and let your swimming pool pump run through the summer. But so as long as we've got some intelligence in this and we understand what we're controlling, I don't think anyone would ever know. There'll be the one time a year that you might go, oh shit, why do I have a bit of a cool shower tonight? Or I jumped in my EV and it's only 3/4 full, not full. Yeah.
But the average drive, I think, in New Zealand is less than 60 kilometers a day. I think it's about 40 kilometers a day. So, like, obviously there's extreme cases, but our devices would start to learn habits of houses as well. The biggest problem around EVs at the moment is all AC chargers give you no charge status on the devices. So that is an obstacle to overcome. But that's in the future. Like we're just talking.
Yeah, what we do. A friend of mine, he's got a iPace, He likes to drive up to Mount Hutt. He has to leave home with a full battery, or when he gets to Mount Hutt, he hasn't got enough to get home, but because it's downhill, he gets home. Well, one day he always programs his car to charge to 80%, right? And he jumps in his car at 6 o'clock. It's 80%. I didn't do anything. He forgot to do something. Well, we're all guilty of that sort of thing. So he had to drive to a fast charger. Grates him like you wouldn't believe. He's got 7 kilowatts of solar batteries. He never buys power, but he had to go to a supercharger and buy the last 20%. And what he said was annoying was he got to the ski slope and missed the first queue. Had to wait. Didn't get up the mountain until 9 o'clock. So we're human. We make mistakes. We're human. We'll make mistakes. But the number of times we do it should be almost zero. And for most people, they'll never know.
So from a technology perspective, there's smart relays in the residential properties. You've got a microcontroller in the substation, looking at the load on the transformer, and you're managing that load in the transformer by controlling the smart relays. So to make that work, I guess the homeowner's got to accept your equipment in their distribution board,
Yep.
which is a conversation. They need to be on a tariff which is beneficial to load shedding.
Yep.
And you need the EDB to be beneficial, open to the idea of putting your equipment in their transformer.
Yeah, there's a lot of hurdles. Yes, we are aware. We are aware.
Okay. we're herding cats here, all right? So, and
Oh,
in fact,
the logic sound. It's
yeah,
just,
the technology isn't really the problem. It's really having the vision to get there,
And the
and then-
society to be there with us.
yeah, and also to find EDBs that aren't too busy in today, and have a bit of a vision for tomorrow.
And
right?
there's interest. There's very serious interest in it. Won't talk to who, but
Yeah, and I mean Australia's going down the path at the moment. Brisbane, Energy Queensland just limited all home charging to 4 kilowatts. So you can't buy a 7 kilowatt. You can buy a 7 kilowatt charger, but it only does 4 kilowatt. Basically, South Australia and Victoria have basically said you can't export unless we can control you, and they're putting a statewide solar panel PV control system in, which is just ludicrous because what they're basically saying is we're going to look at from a million miles up in the sky and make a decision for the whole of Victoria, rather than looking, oh, I've got a real problem here and I need to turn these ones on, but I actually haven't got a problem over here. I could get those guys to go 100%. And that's what they've got to do. And that's what we've got to do. But they're already making dumb decisions because they're panicking because they need to do something fast.
and there's no solution today.
hang on.
Like in South Australia, at least, that they were also looking into dynamic operating envelopes.
Yep.
So it wouldn't just be like a crude kind of curtailment,
But hence
but
the-
that you could have.
Yeah.
Hence the control,
Yeah.
the required.
Oh, so you're saying that they
they're
control
mandating
within that
control.
envelope. Yeah. Yeah.
But
And-
they're not. But they don't have visibility of what's actually happening in the network.
Yeah. which
So they're
is
putting a,
Yeah.
a dynamic operating envelope over a
something
blanket.
that they can't see.
Yeah.
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 And then I thought that they were also trialing in some parts. I think it's a Project Edge where they were looking into having like a distribution system operator so that the distribution system could have some visibility of what's happening in the network. Although I'm sure that that's, you know, a future.
I'm
solution.
sure.
Yeah.
I'm sure they're
Yeah.
probably in similar
Yeah.
phases to us.
Yeah.
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 No, so all I'm saying is I want to run a dynamic operating envelope around the distribution transformer.
Yeah.
And then once I do that, then I can run a dynamic operate around the zone sub, and then I can run another dynamic operating system around the GXP.
Yeah.
And once I can do that,
Got your safety.
the safety barrier, everyone top down, they ask they put their request in and we just deliver it. But until we can deliver it, at the moment we're delivering it by turning off a pot line, by getting Fonterra to turn some stuff off. We hit the hot water ripple. And then if that isn't enough, we then turn off a whole bunch of houses.
Yeah.
And the problem is that the ripple now, there was a bit of a paper I read recently where probably less than
Yeah.
40% of houses have ripple relays that are functioning today.
Yeah.
And then a lot of people, the gen retailers, have disabled them because of the contracts they have with their customers. So how many they actually have is debatable. But yeah, it's,
I actually did have another question, but not to talk too much about barriers, but it seems like there could potentially be some regulatory barriers or at least some standards changes that might need to happen to enable like
There's
to a-
lots,
course.
there's lots
Yeah.
of things. We're
and there's
talking to,
some like immediate kind of things that you would need to change to see this implemented or like
no, at the moment, we've got enough. We just need the industry to be supportive of it and to just, I think the problem this industry has is that it's very conservative. It doesn't like mistakes, but my experience in life is you learn more from mistakes than you learn from successes. And so they need to actually bite the bullet, do a couple of these trials and go, that one worked, that one didn't, and make sure that you document it. My concern at the moment is, and this is quite common in this industry, is they have lots of people called future networks.
They're not the problem.
No, they're not the problem, but they get very excited and then find that a year into the job, they have no budget. So they leave and go somewhere else. And they're not very good at transfer of knowledge from one person to another. So they may have learnt a whole lot, but it all walked out the door. And I mean, I accept that's a problem all over the place, not just in this industry, but when you're in a fast learning curve time frame, you can't have knowledge walk out the door.
Yeah. Thanks. So I was just wondering, are you guys operating towards a specific timeline for, are you working towards a specific timeline for your rollout of all this gear? Or?
We would like our first trial and first bit of hardware installed probably end of next year or early 2026.
Yeah, I'm quite confident.
2025.
We've got a retailer. No, actually, I won't talk about that project. This project,
Yeah,
the
that's one of the
hardware.
things we should talk
Yeah,
about.
there's this project. I believe if everyone gets their ducks in a row, MB's will put money to. They've got a $20 million
Let's not talk to
innovation
funding as well.
fund.
Yeah,
Yeah.
there's
Yeah.
a whole lot of
So,
solutions.
but if it all comes together, yeah, next year is possible. End of next year is possible to start putting stuff in people's houses. And probably 2026, we can write a really nice paper that's got enough data that shows a couple of summers and a couple of springs to give people an idea of what this is capable of.
You can come back and tell us how it went, hopefully.
That'd be the dream.
Okay. What communication protocol do you use to instruct the flexibility provider to turn off this many number of DERs in the area?
At the moment, there are protocols out there like OpenADR, and like, but to be fair, nobody's doing any of it. So what protocol will we use? Because it's our device talking to our device, it'll be our protocol. And what that protocol is, I have no idea at this stage.
Hey, can this technology be used on community microgrids to help improve system stability?
We're doing it with PLC at the moment.
We're doing 5 of them in conjunction with a company called Overlay. A couple up in the Northland, in Northland, and a couple down on the East Coast.
They're mostly in Marae and local iwi, really isolated regions.
They're quite difficult because they want more than just stability of supply. They want resilience after an event, and I don't generate electricity, so it's really hard to. I can flatten their bill, make their bills cheaper. I can manage their batteries for short outages. But if the power's out for 3 days, a diesel generator sounds really attractive.
Okay. With partial work from home becoming a norm, how would a predictive approach fare with fluctuation in daily routines?
Actually, that report from Dunedin showed that during lockdown, behaviours did change a lot. We would assume because water is still a reasonably good thermal mass, that they would still have enough hot water if they wanted to shower at 12 versus 9. They might not have as much though.
Yeah. As long as the hot water, generally the hot water cylinder is going to keep it warm. And because we've now got mixing valves, I think it's about time we started thinking about having hot waters being slightly hotter, so we can use it as a bit more of a battery, so that we may not need to keep as much hot water. We could go to a smaller cylinder. I've done some research recently where we'd be looking at doing shared hot water systems for community housing. You could third the amount of hot water you need to keep hot and you can run it with a CO2 heat pump and run it at about 80 degrees and then run mixing valves everywhere.
I don't think this is a question, more of a warning. Please remember that customer experience is not based on averages. Customers will need ways of overriding what you're proposing for special situations, and of course pay a high rate if they do that.
I definitely think there needs to be a social shift in society, and that will come through education. And yes, there will be mistakes, and I agree that there'll be some people that just won't buy into it. But you know, not all progress is comfortable.
Yep. Sounds as though, so you kind of, the way that you talk about it, it's all automated. So it's almost like the consumer doesn't experience any of this at all. It's just really conveniently happening. But is there a way that it could be designed so that it was tariff responsive, so that you're sending out a price signal that customers understand, so that you can shape their behavior?
We kind of do that already with our pumping systems for these dairy farmers. But so
loading a time of use tariff, loading, it's bad enough. Every dairy shed, every pump has a different tariff rate to it. So we have to load a device and then load their pricing plan. And if I had to do that for every house in New Zealand, I'm not sure unless we can get a much more standardized pricing regime. Someone joked today there was like
EA said there was over $2,000, 2,000 different tariff structures in New Zealand.
Right. Yeah. And so with that sort of thing complicated, absolutely no way. But we, for example, EV charging for what I'm doing in apartments, we have an override button. So you can log into a website and say, I want to charge now and I want to be fully charged in the morning and I don't care how much it costs. All right. And then we will charge you accordingly. Right. But if you plug in and let us thing, then we'll charge at the cheapest possible rate.
I guess the kinds of things that I was thinking about, and I think, is it perhaps what Flick is doing here, where there are, so for example, there's Amber in Australia that was passing on the wholesale cost to the consumer. So then the consumer could be like constantly monitoring the wholesale cost, and you could be sent alerts when there was a high price event coming up. So then you would know to, you know, ramp everything down, and, you know, you could kind of optimize to.
So you're a real geek, aren't you?
Well, I was not a geek, but I was on it, so I had to respond to the yeah. So kind of like it forced you to learn about.
One of the retailers we're working with have a lot of time of use pricing structures.
Yeah.
I think that would be beneficial, but as we would imagine it, the retailer actually wouldn't be the flexibility provider, because we think economically the structures and around it, actually the incentives don't align for retailers long-term to be flexibility providers, because if flexibility providers are doing their job correctly, they're reducing pricing pressures, which is in direct conflict with their maximizing value for their shareholders. And that's the same for generators. So generators, and the dirtiest generators in New Zealand, make the most money on peak when we shouldn't be consuming energy. And we're burning the most carbon, and we're rewarding them the highest price for it.
Yeah. So it sounds like your agreements that say that you were to go through the retail or whatever would be quite different if you were dealing with a gentailer.
I think long term we wouldn't even be, we'd just be a straight up flexibility provider, and then the retailer above would be their own entity. How that looks is probably more like a 10 or 15 year scope than actually like a day situation.
How quickly prices rise.
Yeah, we've got to see, for example, EA, they're pushing the EDBs to drive their off-peak tariffs down to zero, or as close to zero, under 2 cents, but to zero preferably. And they've got to go to the retailers and legislate that they have to pass on off-peak and peak, and they have to be reflective of the market, not reflect, because typically 2 or 3 cents or 4 cents is about as good as you're going to get. Flick is probably the only exception. They will do, they're nearly, I think they're 23 and 12, or maybe something like that. Okay.
There's a
sense to it.
joke in the industry that the only tariffs and lines fees that matters are vectors. Because everyone follows Victor's pricing model and then they do a wash up at the end of the year.
Yeah. So
Because they can't be bothered being sophisticated
Yeah.
enough to understand.
we need a commercial contract for every residential customer. I don't
We
need the
don't need a
contract,
commercial
but we
contract.
need the commercial bill. So we've got all of the lines in
So
there.
that
So you can see that
cost
this is
that
what I
difference.
paid ECA, this is what I paid EA, this is what I paid for the Transpower, this is what I paid for EDB, this is what I paid for peak, and this is what I paid for off peak. That needs to be on every person's bill, and that needs to be legislated.
first legislative change.
Hmm.
It's not the first, but we would like it.
Okay. Is there the prospect of completely distributed smart thermostats and similar devices to modulate use of power based on very small frequency deviations rather than simply on off? Applications might include ramping down or load sharing of EV charges or heating, including water heating and space heating, etc.
Frequency responses of measuring very small ones to do things. I don't know whether Transpower would be very happy about that.
We are looking into it though. We have considered doing frequency monitoring and just having automatic responses in the device, and then it would tell the command hub that it has responded to a frequency event.
Yeah, but
Um,
that's turning things off, not ramping things down. So if we've got a, say 40, when we get say 49, we turn all the EVs and all the hot water cylinders off. And when we get down to say 48.6, we turn everything we can possibly think of off, because we know at 48.3, the lights go out, right? And so there's that technology is easy to do. Using that response to get response on the network, I don't know about that. Because we've got to move real fast. We've got to really move in 6 cycles or a second, 60 seconds, and don't have a lot of time to think about it. Do it or don't do it.
I think we will do it on phase 1 though.
Yeah.
Okay, I think Mike have answered this already. What communications protocol do you use to instruct the flexibility provider to turn off this many number of DERs in the area? Didn't we?
Well,
Yeah.
there are standards for that, but currently there are no flexibility providers and there are no EDBs that have anything that can communicate to a flexibility provider. There are flexibility providers, but there's no EDBs that can communicate anything.
If Open ADR becomes the winner, we'll give them access through our transformer, but not to the individual devices.
Yeah.
With partial work from home becoming a norm, how would a predictive approach fare with the fluctuation in
Yeah,
daily routine? We've
No, we've done this. We've done these.
that one,
Yeah.
How do you make sure that all the customers? How will you make sure that all the customers' energy demand were curtailed fairly?
I think it will be about actually managing the asset, but that would be a social challenge that we'll have to overcome. And we don't pretend to have all the answers today.
Yeah, and remember that our primary, if we take the basis that we're doing a dynamic operating envelope, our first and primary function is to protect the asset. So if everyone on A phase wants to do lots of stupid things, it's everyone on A phase that pays the price. The people that are on B and C phase carry on as normal.
The other component is because we're monitoring these devices long term, we could really not tell the EDB, but we could make firm suggestions around balancing for the EDBs, or make suggestions when actually upgrades are really required. This would help with asset management really well.
Yeah, swapping phases on houses isn't common these days, but it does happen from time to time. So if we've identified that A phase, we're always having to shut stuff down, walk down the street and just swap the house from A to B, and maybe the problem goes away.
Last question. How would this integrate with a BMS?
Via an RS485. Basically, we've looked at our EV chargers integrating with the BMS. So if we're having to clip the charger, we can tell the BMS, and the BMS can ramp down the HVAC systems and turn down lights or whatever. I don't know. To be fair, we can easily send it out through some sort of communication port.
Yeah, so not only got a BMS, you've got more of a commercial building. You've
Yeah.
got the
Yeah, yeah, yeah.
flexibility which comes from a BMS and
Yeah.
energy monitoring
There's
system.
definitely lots of application in commercial buildings, but
Any more questions in the room? We've answered all the questions. I'll take that as a win. I've never answered all the questions before. So thanks everybody who turned up and dialed in the line. If nobody turned up, nobody dialed in, it would be a bit awkward for me at least, standing in an empty room. Big thanks to Alana and the team Engineering New Zealand for doing their magic, and of course a huge thanks to Robert and Ruben for putting your time coming to Wellington and telling us all about it. Thanks.
we appreciate the opportunity.
Oh, thanks everybody.